This conference will now be recorded.
Okay, fine, guys. So basically, we will discuss few of the operations. There are lots of operations we do, so we cannot discuss all the operations, in single day, basically. But let me run through few of the DBA activities, DBA daily activities. These are all, I'll run through every operation that we do as we move on. Don't think that these are the complete operations, but generally, on daily basis, what do we do? The major, you know, responsibility of కొంచెం loudగా చెప్పండి. Oh, you cannot hear me or what? You all can hear me, right? Comfortably?
Yeah,
Hello?
we can hear you clearly.
Okay, fine. So primary responsibility of a DBA is to backups. First, backup. Backups are successful last night, all full differential log backups. You need to monitor. All backups are successful. What are the reasons backups can fail? We'll see all the reasons actually. The backups first. Like you might have a fulls and diff backups and log backups. Okay. These are the backups we do monitor. If anything, any backup is failed, you have to run. Generally, the backup, we need to give a high priority to the backup. Like even if you come to, no bit late, business is starting, still there is no backup, you have to run the backup. Basically, backups are very important to run. Even your business is started and you forgot to run the backup is failed, you forgot to run the backup, still you have to start it. Because if the database is crashed, DB are, primary responsibility is the recovery, basically. So then, like we do weekly basis rebuilding index, daily basis, daily reorganizing indexes, and update statistics. Why we do, I'm going to talk about this, no need to worry. Update statistics we do, and weekly rebuilding indexes, and check DB. CheckDB is also very, very important to check the data integrity on the server. If you don't do the CheckDB over a time, if any page is corrupted, any data is corrupted, you will not come to know. So CheckDB is something at least weekly we have to check on the servers. After that, jobs monitoring. Jobs monitoring every day. There are lots of jobs will run on the server basically. So there are a lot of reasons why the jobs will fail. I am going to talk about all the reasons, general reasons why the jobs fail on the server, basically. Okay, we are going to see all this. So we will configure the backups through maintenance plans. We'll talk about the maintenance plans today. So the major discussion today is about the reorganizing indexes, update statistics, and rebuilding indexes. Basically, these are the three topics I'm going to pick for today as a part of daily activities. So there are a lot of other operations we do, guys. Lot of other operations. So as we move class by class, I'm going to cover up, all the operations, all the configurations, all the issues in the each and every technology. But in a single class, I cannot talk all the technology. So just I'm going to talk. These are the things. Maybe you might be having lots of doubts in this area, and there will be lots of question on this area in the interview, especially in the performance tuning. So let me talk about this, and slowly I'll come back to the creating the maintenance plan. How do we clean up the backups? How do we retain the backups based on the retention policy? And what are the reasons backups can fail? All that we'll talk about. Recovery, we are not talking today. Recovery, it is a one class. How do you recover? What are the sequence we follow when we recover the data? That and all, I'll cover in, backup restore. I'll come from the beginning, installation, post installation configurations, then come with the system database configuration, then come with the security, backup restore, lock shipping, mirroring, replication, clustering, performance tuning, and then always on. I'll come in that sequence once we after once we do the today's class discussion. So let me talk about the indexes. What is the importance of indexes? Having an importance, if you don't have index, what happens? How does it impact the database performance? So that's what I'm going to discuss now. So I just took the, anyone have any question? So Sagar, you can unmute it, mute it actually. So now, if you have a question, unmute and then ask, guys. So now, example, I have a table like this. The table table has lots of data, as you may guess. So how the index actually plays a role, I mean, I'm going to talk about that. So so data will be within the table like this. In the table, like you'll have columns and rows format. So example, I have a data like this, 1 to 1000 rows I have in a single table. If a table does not have any index, that table called as heap table basically. Heap tables are very bad perform, these will create a very bad performance on the system. How they create the bad performance means, example, I have 1 to 1000 records in the table. I wanted to, this example, this table name is just a student, as a case. If I wanted to read some data from this table, how would I read it? Actually select asterisk from student, where s number, maybe this is s number, s name, something like that, equal to 10. I wanted to read this particular record. So if I don't have index, how the system will scan for the data? It will go to first record. No, the criteria is not matched. It's not 10. It will go to second record. No, it's not 10. Like that, it will scan for every record till the number is matched. So it is reading all the 9 records before 10, because before 10 we have 9 records. It is trying to match each and row by row. Wherever the condition is matched, then it will start pulling the data, and then it will display the data to the requester. So where your data is not getting read effective manner. If I have thousands of pages, I'm reading a huge data. Example, I'm giving a range of data. Then that time, if you don't have indexes, it will create a really bad impact on the system. Though you have a really good RAM, really good CPU, really good disk IO, still you'll get the bad performance. It's not the thing that you have really high configurations on the system. You did not configure the system well. That's why you're seeing the bad performance. There are lots of instances we do work on the performance tuning. When it comes to the performance tuning, I'll discuss a lot many things, guys. I'm really expert into that area. When we start the performance tuning, I'm going to touch base lots of things in the performance tuning, at least of 20 to 30 different areas where we can tune the system to work properly. So heap tables are very bad on the system. They create very bad performance. So if I create the index example, how does system behave basically? How the index is helping the system to get the data on faster manner? Let's see that. So when you create an index on the table, first it will create a root index. And by default, an index will have 2 pages by default. Okay, 2 data pages. And what is data page again? Data page is something. Let me explain if someone don't know anything about data page in the SQL Server. Data page equivalent to 8 KB, the storage value of one data page. So see, a database will have a extents will have the pages basically. That I'll discuss in the database architecture when we come to back to the discussion into the sequential order, installations, post installation, database and all. There I'll talk about. Just understand that there is a data page. Database will have a 8 KB. 8 KB in turns will be, it will turn into bytes. 8 into, so how many characters this page can take? Single data page can take 8 into 1024 characters it can load, which means that 8190 total 8192 characters this single data page can take. 8192 characters, I mean to say. So now I have this table just now. I said, to just try to follow, guys. The beginning it will be like what I'm trying to talk here you don't understand, but slowly you'll understand. So this is a student
Ravinder,
table.
okay.
Yeah.
Ravinder, actually, actually, out of 8192 bits, so in a database, only should occupy 80% of the
I know. I'm going to talk about that. You're talking about header part. You're talking about row offset. We are going to talk
yes.
about that. No need to worry.
Okay, thank you.
That part I'm going to explain. Actually, you can data can be loaded into 8060 bytes only, not all the 81692 bytes. 8060 only. That is a page architecture. I'm going to talk about that. It is, there will be in each page there will be header and then will be row offset. There are two portions. This is something 60 bytes or something total. The difference. We'll talk about this, guys. No need to worry. Just take it as an example here. Like single table can single page can take these many characters. Okay, not 8192, but there will be header and the row offset. We'll talk about that. So here I have a table called student, and here I have the columns like S number, S name, and here address, kind of. Fine. So S name is an integer. It is an integer, so it is equivalent to, like 4 bytes integer. And name equal to character. Example, it is 100 bytes I'm trying to do, because varchar 100 I define maximum. The name of a person is 100 characters maximum. I'm going to keep address as well 100 characters, assume a case, just assume a case. So total, to load a single row of this table, this table, how many bytes I need? 204 bytes generally. If you look at here, 204 bytes I need to load single record. 204 bytes. Why? Because this is an integer. It can take up to 4 bytes, and S name I have defined as varchar 100. Address I have defined as varchar 100. So maximum single row can take 204 bytes. So 204 bytes means how many records data page can hold here. How many records it can hold? 8060 by 204, right? 200. Let's assume that this is 200, this is 8000, just for the assumption. So now if I do this one, a 40 rows can be loaded into single page. 40 students information I can load in a single page, assume a case. Okay. If I have extra column, called email address, of the student. So this is also taking 200 bytes. 200 bytes means total how many bytes now? 204 and 204, now 404. So in that case, I'll go with the 400 here, and then 8000, to equivalent to 20 records. So as the row size is growing, as the number of columns are growing, the number of records can fit into single page will change because of the data size for a single row. So why I'm talking all this hell, actually, right? That is I'm coming to that right point, actually. So when I create an index, by default it'll create a root index, basically, by default. This is architecture. You cannot physically see. You cannot even query that this is occupied. You can see actually how many pages it is occupied, but you cannot see the structure. What I'm going to explain, it is a background system will automatically function this way. So when you create an index, basically it will have two data pages by default, two data pages. One, like it will like a tree structure always. So here, this can hold how many records here? As per our discussion, 20 records, one single page, because I created 4 columns into it, and the email is 200, varchar 200, and address is 100, and the name is 100, and the integer is 4. So 404 roughly. Each page is holding 20 records, assume a case. Keep that in mind. 20 records each page. Now, how many records I can load here? Basically, how many records? 20, 20, 20 and 20. Okay. So it's not like that. Let me take this out and then explain this. So by default 2 pages only it will create, but as data is growing, it'll introduce the number of pages here in this range. Lots of pages at the same range. Lots of pages keep coming into the queue, and then here 1 to 20, and a single page is holding 20 records as per our discussion, 21 to 40, like that. Here you have 1 to 1000 records, or n number of records. So what does this root index can contain? Basically, so root index can contain starting value of each page. So I have the 1, then 21, and then 41 and 61. Why? Because 1 to 20, 21, 40, 41 to 60, right? And here 61 to 80, like that. So the pages are, each page is holding 20 records as per our example. So now what this root index can hold here, the starting value of each page, 1, 21, 41, 61, like this. If I wanted to read a page between 80 to 100, 80 to 100 are 40 to 60 example. I wanted to read the data between 40 to 60. How will I write a query example? Just range query. People will write like this: select asterisk from student where s number between 60 and 80. If you run this query, what does it will? It'll pull the record 60 to 80. Now, so what the system will do in this case, as I have the indexes, it first system will contact the index page. Okay, index page is saying that where the 60 record is starting. 60 is recording here in this page directly. It is pointing to this page because it has the indexes where the data is actually sitting. First, it will go to this one for first record, 60th record. Then it will start reading the data from here till the data is ended. 3 pages you have the data, 2 pages actually. So 60 is here, the next records are sitting in the single page. So I'll read only 2 pages and I'll give the output to the requester where I no need to scan this one and get the data. Why? Because I have the guider here. The index is a guider for the system. For the execution plan, the system will contact the index and the index will guide the system to go to where the data page is sitting, in which the range of the data is here in the root index page. The root index page will guide the system to go that particular page and start pulling the data, so that it's not scanning the data row wise. In the previous case, row by row it was scanning where the heap tables are there. When there are indexes on the table, system will not do that way. First it will contact the root index, and the root index will have the starting value of each page, only the starting value of each page: 121, 41, 61, 81, like that. Okay, then the system will get the faster response. Why? Faster retrieval of the data. Why? Because it knows where the data is sitting, in which page it is sitting. Okay, fine. So like this data is just growing and growing and growing, and the pages are keep coming as the data everyday basis. Lots of data is coming into the system. Now one thing, this is also a page. Root index is also a page basically, and this is also equivalent to 8060 characters. I mean the data portion where we can load. Actual page size is 8192, but data portion is 8060 itself. So how many pages information it can hold? Actually maximum, each integer, I said integer, roughly it can take 4 bytes, 4 bytes of storage basically. So how many pages information it can store? Divided by 4, each integer value equal to 4, and the number of bytes it can store is 8060. So equivalent to, so 2016 pages database information it can store maximum. The root index is also a data page basically, and it can hold 8060 bytes of information. You are loading the numbers, each number is 4 bytes. 8060 divided by 4 equivalent to 2015. So this particular index page can hold up to 2015 pages information only. Once this page like completely occupied, which means that 2015 rows already occupied, pages are already occupied, then the index will get split into intermediate level. The intermediate looks like this. This is a root index. Root index will be split into the intermediate index level, and intermediate index level again will directly pointing to the data. I'm going to explain this in detail. So like this, you have the indexes, assume a case. Here I'm going to finish this discussion with this diagram. This is a very important question for the interview, especially. There will be lots of questions on this one. I'm going to discuss the interview questions. So this is intermediate. These are intermediate indexes. These two are intermediate indexes. Fine. Now, as for the previous discussion, now here data has been like 2015, then 2016 page will come up right after 2015. So once 2016 comes up, then index page will split into two pages, which is into the intermediate index pages. When it is splits, it will divide the data equally. 2016 pages are there in this root index. Now they will be divided like this: 1 to 1008 pointers here, then 1009 to 2016 pages information. It will equally divide when the index page splits happens. It will divide the pages information into the intermediate indexes equally. 2016 total pages count here, right? So 1 to 1008, 1009 to 2016. Now the rows of the each, like how many rows we have discussed in a single page? 1 to 20, maximum 1 to 20. So 21 to 40, 41 to 60, 61 to 80, like this. So what is the data I will sit here again? Here what this page will contain? 1, 21, 41, 61, then 81 and so on. So till 1008 pages information, because it is already allocated number of pages. Here again it will start with the 1009 to 20 again. After that 1009 to then 1029, like that it will follow. So if I have to read a data between like if I have to read a data between 800 to 900, then what does it will do? First it will contact the root index. What the root index will have here? Root index will have only two values now, 1 and 1009. That's it, only two values. So now I am reading a data between 800 to 900. So first it will contact where the data range is falling, 1 to 1008 only, because I am trying to read the data between 800 to 900. So index will go through this route and then it will look for the data range. Where the 800 is starting, it will go to that particular page and start reading the data out. So it will not go through each page that you have the data. Why? Because the index is guiding the system to where the actual data is sitting, then fetching out the data, right? So if you don't have index, this kind of architecture will not be there. System will try to read every page on the database, I mean in the table. Every page, a table can have multiple pages, where the like if you have more and more data is keep coming, you will see the more and pages are allocating to the table. So we are talking about at page level discussion and table. This is a single table architecture altogether. So now we do these kind of operations. Which one? I said reorganizing indexes, update statistics, rebuilding index. These are all related to index. Why we are doing that? What is actually the advantage we are fetching out of it? That is a discussion now actually. Why we are doing on daily basis? Just I given a background and the index. Basically, if you have index, system will have a like a reference of the pages information where it can go and get the ready-made data based on the condition you are writing. There will be lots of data retrieval, data read operations. All read operations will use the indexes to write the data. Okay, so now what happens? Let me explain one thing. So if data is actually 8060, right? I said if the data is completely filled, it will go to the next page. If this is filled, it will go to next page. Like that, it went to this page. How many pages? 2016 pages. It went up to 2016 pages. Now what I did is, because of some requirement, I had deleted, like 10 to 11 record. Two records I have deleted. Assume a case, just I deleted, and then I reinsert the data. 10 to 11 data again I reinserted, deleted and reinserted because of some requirement. How it inserts the data? If you delete the record from the page, from the table, page is already allocated. Even you delete from the table, the page space will not be released to the OS. It will not be treated as a unused space. It is already used. Though it is not used by the data, it will be tracked as a used data. So now if I have to load 10 to 11 records, I deleted, I am reloading it, it will go to the last page. Data will go to last available page. 10 11 will come here. So one thing guys, you need to understand here, when there is a delete and reinsertion of data happens, data will get fragmented. What is the fragment means? The data now getting is fragmented because I deleted and reinsert. When I'm reinserting, this page is already marked full by the system. I cannot reinsert in the same range. It is going to the last available page here and it is getting loaded. 10 11 10 and 11 records are here. Now I wanted to read 10, 11 records. System come to this page. The index page is showing that the data is in 1 to 20 should be in this page, but the data is not here. It will search this page. No, it's not here. The search in this page, no, not here. It will scan through every page that is available for the table. Okay. So till it finds the data. So very badly, even you have index, if the data got fragmented like this, it is equivalent to you don't have index. Why? Because it is going through every page till it finds the requested record within the table. So it will scan through every page. So data got fragmented. That's why this kind of operation the system is doing. So this is a case like, yesterday your job running for 5 minutes, but today it is running for 1 hour. Yes, it happens. Because why it is happening? Because the data got fragmented. They have done lots of updates, lots of reinsertion, lots of deletions. So because of that operations, the whole structure of index structure is intact, but the data is not in the page where it has to be. It is moved to the random pages because of the operations. So index is pointing to particular page, but data is not there. Data is somewhere else. System will scan through every page till it finds the data. So that time your performance will get degraded, drastically come down in one day itself because of some updates, because of some deployments, because of some operations the people have done. So these are all general. You cannot avoid, right? You cannot tell them, the people that don't do the delete and reinserting kind of. It's a business requirement. You cannot say that. So to maintain this fragmentation level, we do the rebuilding, reorganizing, all that. So I'm going to explain that with this example. So let me come back to the fragmentation. The overall concept behind I'm discussing is fragmentation itself. So let me talk about.
Yeah, okay.
Yeah, go ahead.
Ravinder, actually, are we able to insert the record and delete the record? I hope we don't have a privileges, right? Like only developers having privilege to delete the record and insert the
You
record.
don't
Like,
do it. You don't do it. Developers only do it, but they are inserting the data, they are doing the operation, but because of their operation system performances went down, right?
this is
They are
understood.
they are doing from the application. The data is getting fragmented because of their operations, and
Okay,
because of that, system performance went really worst, and we need to rectify it on daily basis
okay,
during the
okay,
index maintenance.
okay,
So
okay.
fragmentation is again two types actually: internal fragmentation, external fragmentation. Both are bad actually. We'll talk about that when internal fragmentation will get created, when external fragmentation will get created. So internal means if I'm like 1 to 10, I have like 1 to 10, just like here 1 to 20, right? I have deleted 15 to 19 records, assume a case. If I reinsert the same data, it will not be loaded into this page because it's already tracked as a full. Now it will go to 15 to 19 here in this page. So within the pages, data is within the page is not in the order. It has to be in the order, right? But it is not in the order because of delete and reinsertion operations. This kind of thing is called internal fragmentation. This is the internal fragmentation. What we are talking so far is the internal fragmentation. Okay. Now assume a
Come
case like,
yeah, can you come again? Like, I beg your
yeah,
pardon. Like, internal
fine.
fragmentation.
Internal fragmentation means 1 to 10, 21 to 40 here. I'm deleting certain records, 15 to 19 records I have deleted, and there is a requirement I have to reinsert it back, or else it is taking the missing record count again. Like you deleted, the row ID will be taken back again by the new records. In this case, what happens, this deleted portion is treated as a like occupied by the system already. Once it is full, marked full, it will be full. So next, whatever the data you insert, it will go to the next available free page. Actually, next available free page is 1000. This is 1016. This is a 1017th page basically, and data is loaded 15 to 19 here. Why? Because you reinserted the data here. So once you reinsert the data, it came to here. Why? Because all these spaces are occupied. If these spaces are free to occupy, then it would have been come to this page itself. This is already marked full. That's why it came to here. So within the pages, data is not in the order now. Order is missed. This kind of situation is called internal fragmentation. Data within the pages is not in the order. That situation is called internal fragmentation. Data within the pages is not in the order. It has to be 1 to 20, means it has to be 1 to 20 in this page only, but it went to this page because of the operations. This situation is called internal fragmentation. The order of the data within the pages is not in the sequential. That is called internal fragmentation. Then what is the external fragmentation? This is something at physical level. Physical level means, let me talk about this particular thing especially. So what I'll do, I'll make this bit bigger so that you'll understand. I'll try to discuss. Catch it, guys. These are very frequently asked question in the interview, so pay attention. Fine. So a database example, this is a database. A database equivalent to how many tables? You don't know how many tables. It depends on purely business. A database can have 100 tables, 100 tables. And just I'm taking assume a case, 1, 2, 3, 4 tables, 5 tables, 6 tables, 7 tables, 8 tables, like this. So now if I create a table, if I this is the database, guys. This is the database, and these are all tables within the database. Which one? Each are tables I'm referring here. This box means when you create a table, by default it will pick up a page automatically. It will have its own one single page, even if you don't load any data. This is a page for this table, and this table also will have one page. Just try to understand. So like this, every table when it is created, it will occupy one blank page by default, though you don't enter any data. So this is the first table, this is the 100th table in the database. Okay, this is the first table, this is a 100th table, and this is the 100th page in the physical order. Okay, page number 1, this is the page number 1 physically, this is the page number 100 physically. So now the first table is occupied one page, which is called 1. First table occupied a page called 1, and this page is filled. This page is filled. It require one more page to load. Why? Because the page is filled. By the time it is filled, the page, the next page available physically is 101 page. Physically, I mean to say, the page order physically in the storage. The first table filled up one page. Now it required another page because it is getting the new insert operations. By the time it is required one more page, it is a 101 page physically. Okay, physically. So this situation actually happens every day. This cannot be avoided. How does it actually impact the performance? I'm going to explain this, no need to worry.
Okay,
So
like
here,
any
uh-huh,
newly inserted, sorry to interrupt you, like
uh,
any newly inserted records will be stored like not subsequently, like it will be storing in a another like final page. You mean to say that?
I mean to say, like you have 100 tables. 100 tables by default will occupy 100 pages basically. What I'm trying to say, let me explain this separately. So disk is like this. Each disk will have it, like a cylindrical,
I'm
sectors.
sorry. Ravinder, I got a like I got a call, so connection got disconnected. So can you repeat? I request you, please.
Yeah, fine. So here I mean to say a database have 100 tables. 100 tables by default will take one page at least. When you create a table, it will occupy at least one page, like though it does not have any data. Why? Because it has to load data if any data comes into the table, right? So in the background in the storage, it will lock one single data page. So when I did not insert any data here, it is holding with only one page. But after that, I created lots of tables in the order, physical order. It is occupied its own pages like this. So the first table occupied the complete page. It required one more page because the data is keep coming in. Next page, it is when it is trying to occupy, the page number is 101. Why? Because the first 100 tables occupied the all next subsequent pages that are available. So like that, it is occupied one more page. By the time it is occupied this 101 page, and then it takes some time, right, to fill up this page, maybe based on the operations. By the time it is filled up, next a subsequent page is also being occupied by other tables. This is also required this table, this one is required this table, this page, like this. What I'm trying to say here is, this is very important point you need to understand for sure. So each table will occupy a page. Based on the operations, a table can have sequential order of pages. A table cannot have a sequential order of page, depends on the operations we do. If I'm doing the bulk operation on the table, then it can occupy the all sequential order pages. Why? Because you are loading all the data at a time. But there will be some kind of operations on some tables, like they'll insert very few records everyday basis. See, if it is a school example, how many people will join as a new admission? Like very few people daily, right? So when they're inserting a row, that what one page can be sufficed beginning days, but as the people are joining and joining, they need more and more pages because they are loading lots of students information. That time they need the pages. When they are needing the new page, it is going to occupy a new page that is not in the physical order. Maybe this will be a bit
Yeah,
confusing for
yeah, understood.
everyone,
Understood.
guys. If you have any question, please ask. Like, it's not one way discussion. You can stop me at any point of time, because it's something a real time discussion. It's not like I am telling and you guys are listening and then that is the end of the story. You have to keep ask your question if you have anything in between. That's absolutely welcome. So now here
Uh,
external. Yeah.
Ravinder, I have a
Yeah,
doubt.
Sagar.
So
Yeah, yeah.
usually we will not have the same kind of data in a tables. Generally, there may be integers, there may be sequential
Right,
order,
right,
or duplicate records, or many other
right,
different
right,
kinds of
right,
data.
right,
So
right. Go ahead.
there should not be one type of index that can be acknowledged or that can be referenced to. So there may be different kinds of indexes, right? So
Index, there will be only two types of index, clustered and non-clustered. That's it.
only clustered and
Non-clustered.
okay,
There is no other types. There are
okay,
conceptually, like we do have, like there are, some other index types. They are concepts, they are not types of indexes basically.
okay.
The types of index are only two indexes, two types. One is a clustered index, non-clustered. We are discussing about only clustered. I'll come to the non-clustered index. What the non-clustered index? I'm going to explain, not now.
And how many like maximum that can intermediate indexes can add up? Like if suppose the data is
There is
keep on
no
growing in the end.
there is no limit, guys. There is no limit. Actually, what happens, here also like it started with 1008. Here also, like 2006, 2015, 2016 records came up. Then it will split into another
Okay,
intermediate level here, and here also another intermediate level like this. The hierarchy will keep growing. Like
okay,
as the data is still growing, then hierarchy will come down page by page. Like row by
okay.
row, it will come down.
They need suppose
Mhm.
I created an index on a particular column. So
Mhm.
where I am using in a where condition that I have created one index of that
Mhm.
particular column.
Mhm.
So there will be a physical storage or just references pointers is there
Right, right,
for root indexes.
right. That's correct. Physical pointers, index are physical pointers, of course. The numbers are itself is a physical pointers where they are
Okay,
sitting. It is a page reference basically.
okay. So they need
So
physical storage
yes,
as
yes,
well.
yes, physical storage, of course. These are in
Okay,
the disk actually.
okay,
So, these are all logical pages. All these are all logical pages. Why? Because this is a page number one. This is need not to be page number one. So here it is a page number one. And this is actually page number 101 physically. This can be 500 physically. This can be 600 physically. So the order will not be, you cannot have a like order for the pages. You never ever have this kind of order. Why? Because when the data is getting loaded, a random page will be allocated to that table. Why? Because there are number of other tables are also there in the database, and they're occupying the next available pages, occupying the pages. By the time first table is required, the next page, it could be any number that is available. It can be random number. Getting the point?
okay, okay. Yes,
So when when these kind of situation happens, the physical order of the pages is not in the sequential order, called external fragmentation. External fragmentation cannot be avoided but we can rectify that. How do we rectify? I'm going to talk about that. There is these two concepts will create the performance issues on day-to-day base operations. And then how do we rectify it basically? So how does the physical order will matter to the performance? Let me talk about that very quickly. How does the physical, so if you break the system, you'll find the high capacity DVDs, guys. They are the high capacity DVD drives, like CDs. Every hard disk will have a high capacity DVD drives. The DVD drives will be like designed with the hooks. Hooks means the read write operations will be done through using the hooks only, like this. So now this actually divided into the pages, page number 1 2 3 physically, like this, 4 5, like this 6 7 100 is here. So table 1 occupied first page here. Table 1 required second page, all these space are occupied by all other tables. Now the next available page is actually 100 page. Why? Because these pages are already occupied by other tables, guys. There are number of tables require number of pages. So by the time first table filled up this page, next page it is looking for, the next page physical order is 100. It is storing the next page data here. But when I'm reading the data, I need the first table and second page data. So to pull this record, to pull this page, this handle will work because it is under the that diameter of that handle. If I wanted the next page, this handle will work. Okay. So different handles are serving the request. When different handles are serving the request, there will be IO impact on the system. IO impact. If like if table is occupying first page, second page itself, one handle can serve the request. You don't need other handle, no need to serve the request. So data retrieval will be immediate. This is very back. I'm touching very like background information, guys. If you are following this, it will help you to understand the actual concept when I come to there. This point you got it or you don't get it? Tell me. Tell me.
Understood. Understood,
Uh-huh.
Ravinder.
Understood. Very good.
No, okay.
So yeah, good enough. So now internal fragmentation means within the table, within the pages, the data is not in the order. The order is actually broken because of the operations. That is called internal fragmentation. External fragmentation is the physical order of the data pages. The physical order. This is a logical order within the pages. The physical order of the pages are not in the sequential order is called external fragmentation. These can be day-to-day basis data can be like fragmented internally or externally based on the operations, but you have to maintain it as a DBA to keep the performance better on the system. So how do you maintain it? So on daily basis, I said we do these operations on the index, which is daily reorganizing index, update statistics. So how does it improves the database performance? Let's talk about that. Let me talk about internal fragmentation. Sorry, reorganizing index. I'm going to talk about reorganizing. What reorganizing indexes does when it runs basically. Reorganizing indexes. When we run this command, when we run this particular command, it will scan through every page and 15 to 19 record went into here, right? It will pull back this data into this page automatically. It will pull this 15 to 19 to here automatically. Why? Because the reorganize index, what it does, it scans every page and it looks for the data is in the order or not. If data is not in the order, it will adjust the data to the previous pages where it has to be fit in that page itself. What I'm trying to say, see here, when I do the reorganize indexes, it is scanning all the pages first. Once it is scanned, then what it does, it will do this 15th and 16th should be in this the first page because of the order is the index order is saying that 1 to 20 should be in the first page. It will get these two rows and fit into this page because you deleted the record and this page is free at the moment. It can fit into this page, but there is a huge disadvantage when you do this as well. What is the disadvantage? Let me talk about that very quickly. So here 15 to 19 records have been deleted and reinserted. It went there. Here 60 to 80 I have deleted 70 to 75 records here, but I did not re-enter. See here, I'm here 70 to 75 records have been deleted, but I did not reinsert it. When reorganize happens, there is a scope. What it does, it will readjust the data in all pages. So here 15 to 19 have been moved to the first page. That is a really good thing. Why? Because it is maintained the order. But 60 to 80, there is a 5 records have been deleted. 5 records have been deleted. When it is deleted, this space is free in the page. Why? Because you deleted it, you did not reinsert anywhere, it is just left blank. So that time what it will do, 81 to 100, right here next page is 81 to 100. So from this it will move the 5 records to this page. Why it is moving 5 records to this page? Why? Because there is a scope to keep the 5 records into that page. There is a scope 72 to 75 records are not there and it is empty, then it will move the 5 records to here and then 5 records to here, 5 records, like this. It will keep adjusting page by page and fit the data into each page. 1 to 20, 21 to 40, 40 to 60, here 61 to 85. Why? Because there is a 5 records are missing, they are, we did not enter it. So each page contain 20 records, right? So reorganizing does not know that these 5 records are, like they are reinserting or it can be reoccupied. Does not know, it has to maintain that 20 records into that page, that's it. So then in that case what it will do, it will move the, it will move the 5 records from this page to this page. Why? Because there is a scope to accommodate 5 more records into this page. When it is reorganizing, reorganizing means sorting the data within the pages, guys, that's it. Sorting the data within the pages, and each page it will make sure that each page will have a 20 records. That's how the page is fitting, right? Each 20 records, when it is having the 20 records, then it comes with a 61 to 85. 85, this will come to 86 to 107, here 108 to 20 records, right? 129, like that. So now the complete order is broken. Why it is broken? The index page is saying that 60 to 80, 60 to 80 is in this page, the index page, but the data is here is 60 to 61 to 85. This index did not get updated when you do the reorganizing indexes. Reorganizing indexes blindly moves the data within the pages in the sorted order, and it does not know that when there is a scope to move the records, it will move the records because there is a scope to move 5 records. It is moved, and all pages it will 5 records will be moved, readjusted in each page. Then complete order of the indexes is broken. These indexes are useless now. Why? Because reorganizing indexes resorting the data in all pages, all data pages. When it is resorting the data, there is a scope here 5 records to reaccommodate. That's why it is moving the 5 records to here, because it's empty where it can accommodate. When it is moved 5 records, all subsequent statistics have been broken, completely broken. That's why if you do the reorganizing indexes only, then you are making the system really bad than it was, very bad. So for that reason, what we do immediately after running this, you have to do the update statistics mandatorily. It is a mandatory. If you don't do this, then like system performance will become the worse than the before. Okay, what does update statistics do then? What does update statistics do then means these new indexes have been came up, right? So here 61 to 85, then it started with 86, then 61, after 61 this will become 86. New indexes will get updated here, new indexes which came to the pages after the reorganizing, it will update it here. So now if I wanted to read 60 to 85, it is directly go to there and read the data. Got the point or not?
Actually, I have a doubt on update statistics, and
Yeah,
prior to
yeah,
that,
go ahead.
actually,
Mhm.
like people will say like a reorganization index will affect only on leaf level index, right? So what is mean by
Leaf
leaf level index?
leaf level means data. This is a root index in the terminology. Root index. This is called intermediate index. This is called leaf level indexes. Means leaf level indexes are data level indexes. Both are same. Leaf level indexes are leaf level data pages. This is called leaf level data pages. Okay, are data pages. Can leaf level index pages are database. Both are same. There is no difference. Both are same terminology wise. So date index page is index is actually pointing to the leaf level. The at the end is a leaf. It is a branch. This is a trunk. This is a branch. This is a leaf. That's how we treat it as tree, trunk, branches, and leaves. So this is the trunk. This is the branch, and the branch has the leaves. Leaf has the data. That's
Oh,
why we'll
okay.
call it as leaf level index page or data page. Both are same. There is no difference. Okay. Now when I'm doing the reorganizing index, leaf level pages all will be reordered. When it is reordered, it will accommodate the data where there is a gap. Why there is a gap? Because I deleted the 5 records 70 to 75. I deleted, I did not reinsert it. When I did not reinsert it, there is a scope to accommodate 5 more records into this page. Then reorganizing, what it will do, it will move the 5 records to here because the scope is there. Got the point?
Understood.
Everyone, everyone.
Yeah.
Yeah, after reorganizing indexes, the
Hmm.
intermediate indexes data will not be updated. So that we are
Hmm.
performing updating statistics, right?
Excellent. That's correct. That's the exact point what you said. When you do the reorganizing indexes, leaf level pages will be sorted based on the data available. But that time, like the page statistics can be broken. That page statistics will not be updated in the index pages. That time you will have the bad performance. Why? Because index page is pointing to some page, but data is not into that page. So in order to match the data with the pages, you have to do the update statistics. When you do the update statistics, then if there are any data movements between the pages because of these kind of things, all new statistics will update it in the index page. When the system contacts this update the index page, index will exactly point to that page to get the data. It is unnecessarily will not contact the other page. Getting the point?
So, like just now Sagar told, like intermediate indexes will be updated after reorganized indexes, right? So intermediate index means like whatever the predefined index that will be updated, and like how it will be.
See, when it is updated, the existing are gone. These are intermediate because they are actually pointing to the actual data. These are the pointers to the actual data. This is a root. Root means routing to where the actual range is falling. If I read any data, below 1009, it will go to this index. If I read any data above 1009, it will come to here. Going to here, fine. This intermediate index has actual leaf level page information where data is sitting. So it is pointing to this page, but the data is moved to previous page because of the reorganizing indexes. Why it is moved to previous page? There is a scope. This was deleted. This portion is deleted, and this portion was not reoccupied, and there is no range was inserted. This is example 100 to 115. Assume a case. 100 to 115 is deleted, but not reinserted. That time when I'm reorganizing, it has to have 1 to 20 records. 1 to 20 records means only it has 5 records. I have 15 records. I can move from this page to this page. That will be done by the reorganizing indexes. What does reorganizing do? It will scan through all the pages, and if there is any out of order data within the pages, any data which is not in the order, then it will keep the data in the order. When it is keeping the order, it will also occupy the empty pages, empty space created by the delete operations. When it is occupying, it will move the records to one page to previous page. When it is moving, the physical statistics are completely outdated. It will become outdated. When it is become outdated, then system will get the bad performance. That's why after doing the reorganizing indexes, you mandatorily do the update statistics. Catching the point
Okay.
or not?
So after performing the update statistics, so it will point to leaf level page, exactly correct.
Exactly, Flynn. Right, that's correct. Right, that's correct. So
Means
by
update the
doing,
records.
Hello, sorry
yeah,
to interrupt you.
yeah, not an issue.
Uh,
You can ask.
yeah, how many ways that we can remove the fragmentation in a table? Like
There is no.
there
You
is a
have to.
one.
Go ahead.
Here we have one way, like we are reorganizing the index. So
Hmm,
usually
hmm.
in Oracle, there one from one table to other table we can move, or by using export and import also we can remove. Like that,
No.
is there any concept here, or just only the one way we can do?
No, there is no import export concept here. When you export import, what happens, import export is equivalent to rebuilding index. I'm going to talk about that. What you said is about the next topic. No need to worry, I'm
Okay.
coming to that point. I'll compare what you said. So
Okay.
now, by doing these two operations too, guys, if I do these operations, what will be removed? Internal fragmentation will be removed. No internal anymore. Why? Because data is got reordered and also indexes have been updated in the index page. So internally the fragmentation is gone. Internal fragmentation is gone. That external fragmentation still there. Physical order 101 500 all are there. It is not this reorganizing index will not touch the physical order. Physical will remain same, but except within the pages it will keep the data in the order. Whatever the physical pages, it will keep the same. The pages which are occupied by this table, within the pages it will keep the data in the order. That's it. The physical order it will not touch. But how do I wanted to make this physical order also in the sequential order. Okay, for that reason you have to do the rebuilding index in the Oracle. What Who said this thing? Oracle part, Kiran or Prasad? Sagar. Okay.
It's me.
Rebuilding indexes. Rebuilding indexes, exporting a table is equivalent in the Oracle. Rebuilding index. What does rebuilding index do? Let me explain very quickly. So when we do the rebuilding index, I have a database here. This is a live database. Okay. Then you have a tempdb here. Okay. When we do the rebuilding, complete database will be copied into the not database, one table by table. One table, if I have 100 tables, assume a case in the database. If I'm doing the rebuilding on the complete database, we can do it actually on complete database. How do we do? We will talk about. We are talking about why we are doing it. Then I'll talk about how do we do it. No need to worry. First, understand the concept. I have 100 tables. This is a live database. Now I wanted to remove the external fragmentation. Then I am going to do the rebuilding operation. When I'm doing the rebuilding operation, it will pick up first table, complete table into the tempdb, and from tempdb it will reinsert into the existing table. It will overwrite the existing table. What happens in that case? The complete data is getting reinserted at the same time. So it is getting here. One thing you need to be very clear on this one. Let me keep this one table, second table, third table, fourth table, and so on. 100 tables. It will do the table by table. It is pulled one table into the tempdb. Fine. Okay. Then you got the whole data. It will load the whole data back into this table completely at a time. Bulk insert. That is equivalent to bulk insert, which means that so at a time it is loading all the data at a time. Then pages can be in the sequential order. All pages will come in the sequential order. Why? Because you are loading all the data again into the table again. All data you are reinserting into the table, base table. The base table is gone. The existing structures are gone. New structures are coming into the database. Like it is started with 1,000 pages in my case. 1,000 pages is free. Next free. 1,001, 1,002, 1,003, 1,004, 1,005. All will be in the sequential order. Why? Because this table is getting overwriting the existing table completely at the same time. Completely, it is overwriting the table, so it is reinserting all the data. That is called export. What the Sagar was saying in the Oracle also, it will reinsert the data into the table. That time table will be locked. No one can access this table. Why? Because it is loading the data into that table. That's why when you do the rebuilding indexes, it will load lots of log into the log file. Log will get filled out. So how does why it will load? We have a discussion, complete live discussion. No need to worry about that. I'm going to
You mean
explain that when you,
it
yeah.
is duplicating the record, like how it will be like a,
No, it's not duplicating. It's rewriting the complete data into the table. You see,
okay, like init operation, right? Like
yeah,
init
yeah,
operation.
yeah. Within,
Okay.
it is taking the complete table into the tempdb, one table, and it is reloading the complete data at a time into the existing one. So that's why when the rebuilding is happening, you cannot actually access the table, one
Like what
table
is the
by
user?
table.
What is the
What is
user?
the yeah, when it is reinserting it, it is reloading all the data at a time into the table. When it is loading at a time, it can occupy all the sequential order in the physical order. So what I mean to say, This is a disk. Now I said these are the handles, these are the handles. Use I'm going this is it, this is like this. Okay, now I have a thousand, 1 2 3 thousand pages are 1 to 1,000 pages are occupied. Now 1,000 page to the rest of the pages are free. When I'm reloading the data back into the table, this 1,000 page is occupied, 1,001 will be occupied, 1,002 will be occupied, 1,003 will be occupied. Why all are sequential order? Because you are reloading the data at a time. Getting the point?
Okay.
Confusing?
So yeah, my doubt is like, what is the use of that actually? Like, what is the
What is
main
a
use?
what is a use means that I'm bringing the data physically at the same location. I'm not it is randomly occupied somewhere. I'm pulling all
Oh,
the data at one location.
oh, now got it, got it.
So when I do that, what happens here? What happens, data will be the physical order, the physical order will become, example, this is started one only, next will be two, next will be three, next will be four, next will be five, six, seven, eight, nine, 10, like that. The physical order in the table, in the physical, in the storage, they are brought together, the sequential order. So if I have to read this table, they will be accessible by two handles only, so that data output operations are very fast when people are reading it, because data is together. When it is reloading it, it will rebuild the index tree again. So what does this will do, rebuilding indexes will do, rebuilding index, it will wipe off all your data and reload from the tempdb. Take the complete table, take your complete table, one table into tempdb, you have the complete copy of your safe here. Once this is taken into tempdb, then it will start reloading into the existing actual table. Then when it is loading up, it will rebuilding the complete index structure as well. You need to understand one more concept, I did not touch that. So you understood this, right? 1 to 1008, 1009 to 2016. If I load the next page, what is the next page number? 2017. What is the after next page number? 2018. What is the next number? 2019. What is the next number? 2020. So all the pages, actually the higher order, the number is higher. When the number is higher, all will be attached to under this page only, this index page only. It will not go to this index at all. Why? 1 to 1008 range is already occupied. Next range is coming to this side only, 1000 to 1000, what I said, 1 to 1, here 1000 to 2016, 2017, 2018, 2019, all pages will be occupied to into this index only, not to in this index. This will become a this will become an unbalanced b tree, unbalanced tree. This will become an unbalanced tree because of this. Is again, see guys, this is a very important concept in the performance tuning, because I'm going to touch base the performance tuning very in detail. All are internally or externally are dependent on index, the discussions. If you don't understand the index, you cannot understand the 50% of the performance tuning. That's why I'm paying a lot of time here, else I don't have to pay this. I'm going to talk about performance tuning, I'll refer all these discussions there. If you don't understand this particular anything here, you cannot connect there. Pay attention and then ask your question if you don't understand. If you understand this, I'm going to make you understand 50% of the performance tuning based on this understanding. So keep in mind. So now, so what is happening is the new pages are keep coming in, and this table, this particular index, intermediate index page is capable of, like capable of accommodating 1,000 pages more. Why? Because it started with 1,000 only, it is ended 2016, so it is only 1,008 only. One more 1,008 pages can be accommodated in this index, intermediate index. So all pages are, whatever the new pages are coming, they are attached to this only, not to this one. So this will become it is become unbalanced index tree. So when I do the rebuilding, it is taking the complete table into the TMDB and reloading it. When it is reloading it, actually, it will here it is 3,000, assume a case. The pages page count 1 to 1,009 to 3,000. It can be accommodatable. When you do the rebuilding, it will balance the index tree as well. 1 to 1,500 here. Why? Because it is freshly reloading, right? It will build the indexes like this: 1 to 1,500 here, 1,500 to 1,501 to 3,000 here. because it is reloaded the data freshly. When it is reloaded, it knows like how many pages I have, 3000. When I have 3000, it is going to balance the pages into this index tree and this index tree. So,
Actually, hello.
mhm. Yeah, go ahead.
Once we are going to rebuilding,
Mhm.
our actual original database to you are loading the data into temp database.
Mhm.
After that, the temp database records are
Going
come
back to
to
the original.
original base. That time the already existing tables are deleted or
That is
existing.
gone. That is gone. It is coming from the TempDB.
Okay.
It does the row by row, row by row. It
Yeah.
starts row by row. So how does it happen? See, I have second page, first page, and then first page is overwritten with the new data.
Okay.
It is gone. Second page is overwritten. This is gone. Third, it does the data integrity as well. If it fails, it has to maintain the further pages information, right? Whichever
Yes.
the page it is touching, that will be deleted. It reloaded. It's like that, not at a
Okay.
time. That's why it will keep the order and data integrity as well.
Okay.
So what and all it will do in the background, we are going to talk about that again, but understand the concept first. It does the check, check table, check allocations, all that. When I do the actual implementation, then I'll explain that what it does. But actual in the behind scenes, it does the three things actually. It is reloading the data into every page. By doing that, it is actually removing the internal fragmentation. When it is reloading, it is a fresh data. It will be in the sorted order only. Next thing is, it is going to keep the pages in the sequential order, the physical order. So it is going to remove the external fragmentation also. And also it is balance the index tree. It will become the B tree. B tree means balanced tree. When it is a B tree, the performance will be higher basically. So rebuilding index does three things. It removes the internal fragmentation, external fragmentation. It also balances the index tree. In interview you have to say these 3 points. If someone is asking what is internal fragmentation, what is external fragmentation, then get into the answer. That's how you have to answer. Don't explain everything for a single question basically. Based on the question you have to move on. Some people will say everything they know. That is absolutely wrong. They are wasting
Can you
their
repeat?
time. I'm going to
Can you, can you repeat once again?
uh,
I mean,
if
like
I
what is
do if I do yeah if
you
I
told
do the
single line.
single line answer is rebuilding. What does rebuilding do? Rebuilding will remove the internal and external fragmentation, and also it will balance the index tree. That's it. That is the answer you have to say. Immediately if they ask you what is internal fragmentation, the data within the pages is not in the order is called the leaf level data pages. Leaf level data within the pages is not in the order called internal fragmentation. How does internal fragmentation can happen? Because of delete and reinsertion operations or update start operations or like new record operations. When there is a fill factor concept comes into picture. So let me explain one more thing here. I forgot to explain fill factor. What is fill factor actually? So actually, one thing you need to understand. I'm going to conclude this. No need to worry. What is rebuilding does at the end? There is one more point yet to be concluded. Fill factor in the real time. In the real time, we will keep the fill factor as 90 most of the time. We will do 90. What does it actually? What does the fill factor means? Fill factor is available only when you are doing the rebuilding index. Only during the rebuilding index. So rebuilding indexes is doing, it is taking the complete table copy and then reloading page by page and removing the existing page where the reload is happened. When it is reloading, try to catch it guys. When it is reloading, I'm saying to the rebuilding index that fill up to 90% only. Don't fill every page 100%, only 90%. 10% keep as a blank in each page. In each page keep 10% as a blank. Don't fill the complete page at all.
Is
When you
it
are
80%?
reinserting
Like as per
90%.
okay, okay.
Go ahead your question.
Yeah, like people will say as part of Microsoft thumb rule, no, no, actually, I
Mm,
said this word to
Mhm.
some demo sessions for some other institutes. Immediately they have terminated me from the session. I don't know whether you are going to terminate me from session
No,
or
no,
not,
no.
but
Go. You ask your question first.
yeah, like people will say like as per of Microsoft thumb rule, we should maintain 80% of the space, like it will reduce the space split in t ball fill factor will value is 0, right?
I
Like
got
that.
your point, man. Wait. See, here, 80% is something you had. This fill factor goes with the best practices. By default, we'll go with the 90. 80 will keep it where there are lots of, reinsertion updations are happening. There is a more activities are going on. Then go with the 80. There are less, use systems. Go with the 90. Very rigorous. Your people are doing lots of delete and reinsertions. Like when they are doing the rigorous reinsert and deletion operation, lots of operation, then go with the 80. By default 90. If the 80 is exceptional case, it is not regular practice we do follow. 80 is not regular practice, 90 is the regular practice we do follow.
Okay, thank you,
why
thank you.
why it is like that, I'll explain. Just a minute, don't worry. You can ask any question, Sagar. I entertain every question from you and then everyone as well. I'm here to
Um,
explain everyone's question. I'm not
and
going to terminate.
main of the reason for this keeping the 90% fill factor.
Yeah, I'm going to explain that itself. So what is the reason we do keep that basically? Let me open this very quickly and tell you this. I mean, with a bigger picture. So I have these, pages. Now what I'm doing is, these are lots of pages, just a few pages I'm taking. So I'm filling up to 90% only 90%. Okay. Now I said 1 to 20 records are there in the previous case. Okay, assume a case 20 records itself. Just assume a case situation it is. So 40 like this. 41 and 60. Now what did I do? I actually deleted 10 to 14 records. 10 to 14 have been deleted. Okay, if I'm trying to reinsert 10 to 14 again, I have 10% free in the same page. The index is saying that go to this page and load your data, and I have the free 10% space. So here 10 to 13 records are filled out. 10 to 13 means 3 records filled out, but one record is not yet filled out. It's not filling because the space is over. When the space is over, it will go to next page itself to load. 14th record will get recorded here. So it's not going to the last page. It's not going to the last page. So what I'm trying to say, when you are doing the rebuilding index, you can keep the fill factor 90. When you keep the fill factor 90, the data is getting reloaded into the pages, right? When it is reloading to the pages, it is going to load 90% only. 10% will be left free in each page. Now, let's come to the original discussion. Like I have deleted 10 to 14 records. I'm trying to reinsert. The index is page is pointing to me to load into this page itself. This page has some space where I can load 10 to 13 records, but not 14. 14, if I'm trying to reinsert into the next available page, it is the next available page and it has a free space. So it will go to the next page only. It will not go to last page. Previous case it went to the last page. Why? Because all these pages are occupied. In this case, I have the free space in the next available page itself. Catching the point or not?
Yeah, this is improve the performance of the select query.
Right. Improve the performance of select query, trying to avoid internal fragmentation. Trying to avoid, not 100%. You cannot 100% avoid the fragmentation, but trying to avoid the internal fragmentation, we are introducing the fill factor.
And
When fill factor,
okay, query
and
optimization also.
Query, I'll talk about that. Query optimization. I'll show you how to read the execution plans, how to give the recommendations to the project team, or else indexes itself are bad. We are going to talk about that. No need to worry. When it comes to the performance for practical implementation, I'm going to talk about that. But now understand the background thing first. Then I'll go to the practical part. So now we are introducing the fill factor when I'm rebuilding the indexes. Because of why we are introducing this, if you see example, before rebuilding indexes 100 GB database size, 100 GB. after when after rebuilding indexes, it is going to fill 90% only, and 10% it is going to leave blank. So after rebuilding index, database size can become 110 GB. Why, tell me now? Before rebuilding, database size is 100 GB. There was no fill factor. Now I rebuild the indexes. That time I kept 90 as a fill factor. Then it become 110 GB. How?
Because each page you are keeping 10% free space. So
That's correct. That's why your database size, as is into the difference, because you left each on each page 10%. That 10% is actually it is occupying more space in the disk, 10 GB more, and you are occupying the more space. That's fine, but you are improving the performance here. You're trying to avoid the internal fragmentation with the help of the fill factor, and the fill factor concept can only be available when you're doing the rebuilding index. Got the point, Sagar?
yes, yes, we can also
So
shrink the space, right?
You mean to
shrinking
say
is
like
different. Yeah, go ahead.
yeah, you mean to say it will reduce the page split, right? Like page
Right,
splits.
that's correct. That's correct. Page splits means splitting a page means what, going to the different page. That's it. So here, like it's you cannot say that page split. Page split can happen at the index level, not at data level. Basically, index. If this is actually filled out, then it will split into the two intermediate index page level. Page split can happen to the index pages, not to the data pages. Keep that also in mind. So now we are trying to load the data where the range is falling with the help of the fill factor. The index is always guiding your data to go to the respective page only, but there was no scope of to loading the data. That's why it going to the last page. There was no scope here. That's why it went to the last page. But now, after introducing this concept, I have the scope. But why it is 80%? Why it is 90%? When there are lots of operations are going on, and you are keeping 90, still it is not serving the purpose. Then go with the 80. That's it is. It's not like go with the blindly. 80% means you're wasting lots of space actually. Go with the 90. 90 is the standard, not 80. Got the point?
Okay. These are all things to respond the database like as fast as possible. Like how like we are keeping 80%, right? Like so this is
By
for
default, here, go with the 90. If you see the lots of internal fragmentation, then
okay,
reduce the fill factor. It is a kind of R&D, not at one go you apply what you wanted to do.
okay, okay,
It's something, over the time you'll understand what fragmentation you wanted to apply in the tables kind of.
okay, okay,
Okay, so I'm going to conclude this, guys. So you should aware of what is fragmentation. Fragmentation means data is not in the continuous form is called fragmentation. Data is not in the continuous form is called fragmentation. Fragmentation is two types: internal fragmentation, external fragmentation. Internal fragmentation means data within the pages is not in the order is called internal fragmentation. External fragmentation means the physical order of the database are not in the order is called external fragmentation. Reorganizing indexes, it will resort the data within the pages. It will pull the data within the page in the sorted order when you do the reorganizing indexes, but it disturbs the existing physical index architecture. Why? Because if there is any scope to move data one page to the previous page, it will move when it is resorting. That can break the index chain. For that reason, immediately when you do the reorganizing indexes, you have to do the update statistics so that the indexes and the pages will be intact with the latest information. So that something can remove the internal fragmentation. External fragmentation and internal fragmentation both can be removed using the rebuilding indexes. So rebuilding index, what it does, it will reload the data back into the original table. When you are explaining rebuilding index in the interview, just don't say that whole thing. In rebuilding indexes will remove the internal and external fragmentation. It also balances the index tree. That's it. What is internal? Then explain internal. What is external? Then explain. There, your efficiency will come into picture. If you say everything, your whole interview are going in the index itself, how a person can assess you where you are strong, where you are not strong? You're not giving a chance to the person to assess you actually. That's a very bad habit people will have. So be specific to the point when you're answering. Don't say anything extra. That very like bad habit people have. I've rejected many people like that. I'm going to groom you guys how to take the interviews first at the end of the class. No need to worry. So let me, you should aware of all these points. All these points are very important points for the interview. Internal, external, update status, reorganizing, fill factor. There is non-clustered index. Last topic. I'm going to take this and then close this off for today. Let me talk about, this is completely what we have discussed is only index architecture, in a clustered index. This is a clustered index. A table can have only one clustered index, and this is a tree it can follow. The whole index tree is equivalent to clustered index. What is non-cluster? Let me explain very quickly this thing. I have one table and another table. This table is called a product table. Product. And this table is called a sales table. Okay. Assume a case, I have a company, laptops company, or else I'm selling laptops online. Assume a case. Take that as an example. So original table here, let me take this very quickly. Laptop, it is a number, laptop number, laptop name, and quantity, just for the example. Here also same thing I'll follow, number, name, and quantity. Fine. Now initially I have 100 laptops. I did not sold out any laptops at the initially 100 laptops. Here 0, I did not do any sale, so it is 0. And this is the first record. This is the name of the laptop. And next I have done the one sale, it will become 99 in the product table, and the name and the serial number. Just I'm taking a random example to make you understand. Here is the first and name, it is 0 laptops have been sold out. Here it will become a 2 number and the name of the laptop, and the quantity of laptops sold is 1, like this. So it is comes down, it goes up, because it's a sales table, it's a product table. So like this, like at the end your table will become 0 because all laptops have been sold. At the end this sales table will become 100. Why? Because all laptops have been sold out. Now as a manager, as your CEO or whomsoever it is, they need a consolidated report. What kind of report they wanted? Let me take back. They need a report like this because the management people need a proper data they wanted like this. Number of laptops, name of the laptop, and product quantity and sold quantity, like this they wanted the report, right? This is a number, this is a name, this is a product quantity, this is a sold quantity. Just I'm taking an example guys to make you understand better. So now in order to get this report I need to join these two tables. To join, then I'll get this output. Why? Because I'm reading the whole table, this complete table into the report, and this only one column from this table, right? If you look at in this report, number comes from here, name comes from here, product quantity is coming here. Almost I'm reading the complete table into the report. But from this table, what I'm reading, only this portion. That's it. I'm not
So
worried about this. Yeah.
you mean quantity column is a primary key and foreign key, right? Like
No.
here.
Let me wait. I'll explain this.
Okay,
So
okay.
now here you have a primary key. This is a primary key on this table. Here also primary key is this. This is a primary key. Okay. Every table have its own primary key, its own index structure. Product table has its own index structure like this. Sales table also have own index structure like this. They are the independent tables, independent index structure. Got it? At
Yes,
least
sir.
try to understand this. Two tables,
Yes, yes.
primary keys. Two primary keys means two different index structures. Now I'm reading the whole table from this table and only this column from this table. Now when I'm reading only this one particular column, I'm not reading, when I'm reading this one, I'm not using the primary key. Because why I'm not using? Because I need only one this column. This for reading this column, it is going to read every row of this page. Why? Because I'm reading only one column, not this column. I'm not, if I'm in this table I'm including the primary key as well. With the help of primary key, it is going to the index and get the complete data what I wanted as a report. But here I'm reading only this column, which is going to create the performance issue in this query, in this business requirement. Then what should I do to remove that issue? So I am going to introduce a non-clustered index on this column. When you create a non-clustered index, what happens basically? Let me explain this. When you create a non-clustered index, this is 0.
Database.
This will append the primary key values. That's it. It does not do anything. 0 plus 1, 1 plus 2. So 0 is the first number of laptops. This is the second number of laptop. This 1 is the primary key. This 2 is its primary key. So non-clustered index will have the data plus primary key value. Understand that. Non-clustered index will have that column data. Non-clustered index will have its column data 0, 1, and also appending with the primary key values also into that column. We are up when I'm creating non-clustered index on any of the column of a table, it will have its own column data and also primary key data as well. Two data will sit in that. Following or not following? Tell me, guys.
Yeah. So you mean to say
Yes.
database and index base are stored in separately?
Can you come again?
Database and index pages are stored in separate leaf.
Not database, it's a table. It's only the table I'm talking about. Table. We're talking about table now.
Mhm.
Table actually, see here, 1, 2, this is the name, 0 laptops, 1 laptop. Now I'm reading only one this column means I'm not using the this column in any query. Basically I wanted to read only one column. When I'm reading one column without the help of clustered index, then it will go to heap model. It will go to heap model. Why? Because I need only one column from this table. I am not referring to the primary key. When I'm not referring the primary key, it will not go to the index. It does not know index is there or not on this column. This column knows the index is there, but I'm reading only one this column. Where such kind of dependency is there, you introduce a non-clustered index. When you create a non-clustered index, you will have your own column data as well as primary key values also will be appended. When I wanted to read this column now, I have the data, I have the index value. It will go to the index, take this index value to the index page and get the data immediately. Non-clustered index means your column data as well as primary key data, both clubbed together. Following or not following?
Yeah, understood.
So when this
It is
happens, yeah,
hello. It is
yeah,
like the joining the tables.
yes, when you're joining only this required, yes, that's correct. I'm joining the table to get the final output. So that time what is happening is, now let me come to this one. So here you have your data here. I mean, this is actual data, right? So I'm introducing a non-clustered index on this one. When I'm introducing the non-clustered index on this one, this first column row data and this column data will be there. When you know the index value, when I know the data and index value, this one, it will submit to root index. One is into this range, one is in the first page itself, then directly go to this page and get the data and give the report, generate the reports from that table. So so one thing you need to keep in mind, whenever you are reading a column of a table without the help of clustered index on the table, introduce a non-clustered index. That will improve the table performance. Whenever you are reading a column of a table without the help of clustered index on that table, then introduce a non-cluster. When you introduce a non-cluster will have its own column data along with the primary key value will be appended with the data. So when I'm trying to read this data, I have the data as index value. When I know the index, I can go to
So
the index and get the data.
you're saying
Yeah.
primary, like, so primary where it is bringing like zero, like initially zero laptops were sold. Okay, later one laptop sold. So you
Hmm.
have appended 0 plus 1, right? So one,
Yes,
you are saying like
is the
while
primary key
implementing,
value.
okay, okay, while implement non-cluster index, we have to append the primary primary
No,
key.
no,
So
you don't append. You don't append. System will do that.
oh, okay. 0 plus one where you bringing, like, is it getting from product
This
table?
is the one. This is the one. This is the sales table only. The sales table primary key value is sitting here because sales table I am reading only one column without the help of this. When I'm reading a column of a table without the help of primary key or clustered index, then use the non-clustered. That's it. As simple as it is. Why you are using the non-clustered? To have the clustered index value readily available with the data, so that whenever I have to read this data, I have the index. When I have the index, I can go to the index and get the read this data immediately. Still confused? Keep asking your questions. Then I can go with the discussion. Understood or not understood? Tell me, guys. So let me explain very, very quickly, guys. So I have a table. I have a table like this, and this is a student table. Now, like this. This is the last example, guys. Then I'll close the topic for today. I mean, I'll conclude and close. This is a S number, S name, email address, and phone number. And this is a student. So now I have the phone numbers in this page. This is a clustered index where I imposed. This is a number where on the number only you'll create the primary key. When you create the clustered index will form on these numbers, but I'm reading from this table a phone number, random search, email. Basically the emails are here, email so and so, email so and so, email so and so, email. When I create a non-clustered index, this is 1 2 3 4 the IDs of student, and this is the email. So when I create a non-clustered index on this column, data plus the serial number of student, data plus email ID plus this number, the student ID, email ID plus the student ID 3. So why, when I create a non-cluster index, data plus the complete data of that column is going to here. When I have to read this column, only one column I'm reading because of any reason, because of any business requirement. When I'm reading only one column, if I'm going with the email IDs, then it will go with this one. It is not matching. Go to this one, not matching. Go to this one, not matching. It will go in the heap order. So to not to go to that order, what we are doing, we are introducing the non-clustered. When I introduce a non-cluster, data plus clustered index value, data plus clustered index value. When I have to read this particular thing, when I have to read this thing, I have the index readily available with the data. That index will take me to the where the data is sitting. Following or not following? This is a bit of confusing, but you need to understand this.
Okay, when we are talking about non-clustered index, so
Hmm.
suppose we want, whenever we want to read the column level, then we have to append the cluster index.
Don't
You're
say
saying
that.
that
Not we had to append is a absolutely wrong word you're saying. We have to introduce the non-clustered index.
system level.
That's it. Whenever we are reading a column of a table without the help of clustered index or primary key column, whenever we are joining a two tables without the help of the clustered index or the primary key column, then introduce a non-clustered index on that column to improve the select query operation. Why? Because if you directly reading the data, how does the system identify the data? It just go through the row by row. So not to go row by row, we are introducing non-cluster. Non-cluster means your column data plus clustered index data, both. So that if I am reading this column, then I know the index value of that data. Index value means one it will submitted to root index. Root index is saying that this root index should go into this side. Why? Because 1 to 1008 are sitting here. Then it will go to the first page. So data will have your data, the non-clustered column will have your that column data plus clustered index data, both. Understood?
Yeah, yeah, understood.
Very good. So now when I'm
Yeah.
joining this,
So okay.
uh-huh. Go ahead, fast. Go ahead,
Yeah.
fast your question.
Yeah. Yeah.
Hmm.
In the sales table, so reading a column level, non-clustered. So it is appending 2, right? So 2 is nothing but a it's a
Clustered
clustered index,
value.
right? So it will
Right,
directly hit
right.
to root index, and it will, Yeah,
get the data.
it will directly hit to root index, and root index will start searching the fetching the data, right?
Right, that's correct. You got the point at the end. Good. So now see the whole table is reading here. In this table, I
Mm.
no need to create any non-clustered index on this table at all. Non-clustered index is not required because I am reading the primary key also into the report. This from this table, product P number, P name, product name, and product quantity. From this one, from the sales table, I'm reading only one column. That's why I need a non-clustered on this table. I don't need any non-clustered on this one because I'm reading the primary key also into the report here. But here from this table, only one column. That's why I'm introducing a non-clustered index on this one. Got the point?
Clustered index will improve the performance, right?
Yes, yes. Improve the performance because it is having the index readily available with the data. Got it? Yes or no? Tell me guys, don't keep quiet actually.
Yeah,
Yes,
yeah,
yes,
we understood.
yes.
The thing is that in sales table we are not retrieving the primary key index column data.
Right.
So we are only
That's
we are only retrieving the particular quantity data. If
uh,
suppose we are not creating the non-clustered index, it will go in. It will you have to go record by record. To avoid that, we are
that
creating the non-clustered index.
exactly. You got the point, man. That's correct. Oh, that is what I was shouting so far. That's correct. That's correct. At the end, you guys got. So now let me conclude this very quickly. There is a concept called index seek and index scan. What is that? Let me talk about very quickly. Index seek and index scan. These are all questions in the performance training. Very regular questions. What is index seek means? Index seek means the system is containing the root index, going to the index and finding the data directly. Okay. The index seek is directly finding the data. Index scan means it is trying to find the data, but data is not there. It is scanning for the data. So which one is good? Index seek or index scan? Index seek is actually index seek is directly finding the data. The root index has leaf, the intermediate index has intermediate index pointing to leaf level data, and leaf level data found the data. Where that is called index seek. Index scan means it is trying to find, it is going to the page, but data is not in that page. Data is in the other page because of fragmentation. Then it is scanning for the data. Which one is good?
Seek.
Seek or yeah, seek operations are always good in the performance tuning. Scan is the worst thing. You might have data fragmentation. You did not write the query properly because you are reading a table of a column without an unclustered key. That also it will go to index scan. So where it is joining, it is giving the index scan in the execution plan. Scan is not good. You go and check it where they are joining the query. You can see that is how we do the recommendations to improve the performance. Index key seek and scan. I'm going to refer these words many a times. So seek means you are finding the directly data with the help of the indexes. Scan means you are not finding the data with the help of the indexes because data is fragmented. And also this seek will scan will apply to heap tables as well. Where I started here, heap table. It is scanning for the required data. So scan is absolutely bad. Seek is absolutely good for the performance tuning point of view. The terminology is important. So right now, you guys should be familiar with what is fragmentation, what is internal, what is external, what is reorganizing, update statics, rebuilding, fill factor, index seek, index scan, non-clustered. These are the words you should be familiar now. Yes or
Yeah,
no?
if yeah, if the table is fragmented, it will follow index scan. If the table is not not fragmented, it will go with the index seek, right?
Not only fragmentation, there is no index as well. That also will apply the index scan.
Yeah,
Yes,
like full table scan. Yeah. Okay.
yes. Scan goes through two cases. One is fragmentation, other is no index. Yes, that's correct.
Okay. Okay.
So by now, you all should be familiar with these words, right? All these
Yes.
words. What is the
Yes.
meaning
Yes.
of it?
Yes.
So, tomorrow what I'll do, how do we implement this? Okay, we understood this. Like how to rebuild a table, how to rebuild a database, how to reorganize a table, how to reorganize a database, how to update statistics, all that we'll see practically. Theoretically, we understood. But how do you create the maintenance plan to do that? We are going to see that, right? So that's all
Okay.
for today, guys. Tomorrow we are going to talk about the actual practical implementation of DBA jobs. DBA jobs, not the activities, complete activities. DBA jobs. Job means automated jobs. DBA automated jobs that we create, automated jobs on the server. There will be 7 to 8 jobs we create on the server, on every server, and each job will have a meaning, and that will be completed. Then we'll move to the uh, with the course content, right? So
Yeah.
that's all for today. And like I would recommend